Today, our topic is triangulation. So first, let's define what is triangulation. So triangulation is a method for extending horizontal control for topographic and similar surveys which require observations of triangular figures whose angles are measured and whose sides are determined by Chigo computation. So horizontal control meaning your guide points along the horizontal axis. Another way to define triangulation is it's the process of determining the location of a point by measuring only angles to it from known points at either end of a fixed baseline rather than measuring distance to the point directly. So when you measure distance to a point directly, that is trilateration. So that's the basic difference of triangulation and trilateration. Triangulation, you use angles to get the length of a side, and then trilateration, you measure it directly. So there are several forms of triangulation. So here are the common geometric figures used in triangulation. The first common form is chain of single and independent triangles. So this is used when control points are provided in a narrow strip of terrain. For example, a valley between two ridges. So if you do something like that, it's gonna look like this. Okay. So yeah, it's gonna look something like this. So it's a series of triangles connected together in a narrow path. So this is your common figure 1. Next, chains of quadrilaterals formed with overlapping triangles. Now, this provides a means of computing lengths of sides. So an example of how that looks like is this. Okay, so overlapping triangles, let's say that's triangle 1. Triangle 1 overlaps this triangle, overlapping this triangle. Okay. So that's an example of quadrilateral from overlapping triangles. So from this, if we measure a baseline, so baseline is something wherein we already know the distances. For example, if you know this distance and then get angles at each side, it is possible to get the length of the other sides of this field as well. Okay, and then last, chain of polygons or central point figures. So it's used when vast area extending in all direction is required to be covered. So an example of that is you have something here in the middle, that's where you put your station, and you have a set of polygons extending in all directions. So something like this. So that's an example of a third geometric figure commonly used in triangulation. So now for us to better understand the concept of triangulation, let's have this example. Example 1, in the quadrilateral ABCD, the following angles are measured. So angle BCD 33, ABC 34 degrees 30 minutes, ACB 49 degrees 30 minutes, and ABB 37 degrees 30 minutes. So find angles. Okay, so to draw this, if your figure is not given, okay, since no lengths were given as well, or no positioning is given, it's a bit arbitrary. So you can just write this. Okay, since we have 4 points, right, A to D, you already know there's 4 corners to this plot. Also, by the term quadrilateral as well, we already know this has 4 corners. So just draw 4 corners this way. So 1, 2, 3, 4. So this is your A, B, C, D. I like to make the base of my quadrilateral straight just for convenience sake. You can also not draw it straight. You can draw it over here, your point B. Again, this is just for convenience because I start with a straight line at the base. Okay, next, let's draw angle BCD, 33. So from B going to C to D. So that means that's this angle over here. This is your 33. Okay. Next, angle ABC, 3430. So from A going to D, going to C. So this is your 3430. And then ACB, 4930. So ACB, so from A going to C, going to B. So this is that angle. Again, 4930. And then lastly, ADB, 3730. So A going to D, going to B. And so that's this, 3730. Okay, then let's close this quadrilateral. Okay, so that's how that is formed. Next step, solve for angle CAD. So letter A, angle CAD. Angle CAD is over here. So you want to get that. Okay, so one way to get that is to look for your triangles, okay? So what if I consider this triangle over here? N. Okay? Oh. 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 And okay. You can see clearly you have a triangle. And can you tell me what's the sum of the interior angles of a triangle again? Correct. 180. RDL, John. Rapid discal. So using that, rapid discal. If the two other angles of the triangle are given, I can solve for the third one. Okay, so let's see. So I'm looking for this. We can get this and this. To get that, that's just 180 minus the other two angles, right? So 180 degrees minus 49 degrees, 30 minutes minus 33 degrees, and then minus 34 degrees, 30 minutes. We solve, what's the answer? Correct, Zelika? Okay. Correct, Zelika. And Zaira. Another Angel. Okay. So 63. Next, part B. Find angle BAD. So BAD, that's this angle over here. So unfortunately, in creating a triangle out of this, we will consider this one. the given is too few to solve for anything, right? So I can't use 180 minus this because I don't know what this angle is. However, if you've noticed, I can actually solve for this one. Can anybody tell me what is this angle over here? Okay, correct. John K.D. Crystal Escobar. It's 75. Okay. So how did we get 75? It's the same way we got this. Considering this triangle, okay, right? If you've noticed, that's also a triangle. So 180 minus this 33 minus the sum of this. You'll get 75. Okay. So now, I got this angle. Still doesn't help me get this. So when that's the case, you need to use either sine law or cosine law, depending on what's more convenient. Okay, so first, if I'm going to use sine law, I need side angle, side angle. This is the goal to get this. Okay, so if I'm going to use sine law, I need to get side BD. Okay, this is another angle I have, right? So I also need to get side AB. So now the goal is to get these two so that I may be able to use sine law. Again, because sine law is side BD over sine angle equals side AB over this side. Okay? So now let's start solving for that. Let's start with BD. Okay? Now notice there's no given side here. Okay? The only thing we need to solve for is angles. So I don't need an accurate measurement or the actual measurement of a side. So that means I can assume the length of a side. Okay, so assume one of those lengths, the most convenient length, to be equal to 1. Okay, because the easiest to solve for is if your side is equal to 1. Okay, so here, I'm going to have CD equals 1. Now, you might be wondering why. Because I'm going to use this triangle to solve for BD. If I have this as 1, I can use sine law to solve for BD. Okay? So now this is the other angle, right? Well, let me isolate that. So CD equals 1. Okay, so B, C, D. You solve for that. That's 75. This is 33. And this is just, I'll get the sum. 72. Yeah. Yeah, 72. Okay. So using sine law, again, the goal is to get BD. So BD over, so this is sine law. BD over sine, opposite angle. So BD, opposite is 33. Equals your assumed side. So I assumed CD as 1. So 1 over sine, opposite side, 75. Okay, please solve what's BD. Okay. Correct RDL and Kurt. Hasta done. Nothing. Okay. 0.56. Store that in your calculator. Or just write the entire decimal of that. Okay. So now I have BD. Next goal, I need to get AB. Okay. Now, getting AB isn't as straightforward as getting BD. Because The only two possible triangles you can use are this and this. Again, in using this, information is still incomplete. I only know this side and this angle, so not enough. Now, what if I use this one? Okay, the only thing I know from this triangle is this angle and now this angle. So it's not straightforward. My lengths or values are incomplete. So I need to solve for another thing. Wait, question. Wait lang, there's a question. Yung quadrilateral is, hindi po ba dapat same side yung AB? Same side? AB? Hindi po ba dapat same? I mean, want it this way. A, B, C, D. A, B, C, D. Okay, let's try it that way. Why we can't do it this way? So the question is, why is it this way, not like this, where AB is at the same side? Right? Is that your question? Okay, well, first of all, if you do it this way, BCD is 30, okay? 33, which is impossible, because even if you put it very far away, this is still a very large angle. So let's try that. 33. So ABC 34, ABC. Okay. 34. ACB 49. ACB and 49. Okay, so this is where the problem arises. By drawing, this angle should be greater than this angle, but by value, it doesn't hold truth. So there's a conflict. Okay, so that's why I can't draw it this way. Okay. So that's how I know it's this way, because all of my angles check out. There's no conflict. Here, there's a conflict. This is 33. This is 49. That can't be, because this should be larger here for this kind of drawing. Okay, so does that answer your question? Okay. Continuing on. So as I was saying, I need to solve for a value in order to continue getting AB. So obviously I won't be able to use this because there's too much unknowns. So I will be focusing here, right? Now, if I use sine law, I have this side opposite this side, okay? And then, I don't know. So focusing here, if I can manage to get AC, A, AD here. If I can solve for AD, I can solve for AD using cosine law. Okay. So to get AD, sorry. So scratch what I said earlier. So I'm gonna solve for this because I already got BD. Okay. I got two angles and the included side. I can solve for this using cosine law. Okay. Because for cosine law, I just need two angles and the included side. Sorry, two sides and the included angle. All right. So now the goal, get AD. So to get AD, look at what we have. I've assumed this already to be 1, value 1. I got this angle, this angle. Okay. I already know this, we've solved for that. So that means I can use sine law. So this is 63. Let's use sine law. Again, the goal is to get AD. So AD over sine this. So 49, 30 plus 33, that's 82, 30. AD equals our CD, which is 1, over opposite angle, which is this. Again, we're considering this red triangle. Let me specify that so it's clearer. ACD. 63, 82, 30, 30, 34, 30. Okay. And as you can see, opposite of CB, this is 1 sine 63. Okay, please solve what's AB. Correct, Geraldine and Jasper. Lazaro, the end. So it's 1.11. Once again, store that because we're going to use that later. Okay, now I got this side. I got this side. I'll use cosine law. And remember, cosine law is just side squared. So AB squared equals the other side. So BD squared plus AB squared minus twice BD AD cosine this one, 3730. Okay, please solve what is AB. Considering this is BD and AD. Okay, correct, Zelica and Micah. Polycarpio. Sorry, no. So, Zelica and KB, Escobar, Angel. Escobar. It's 0.74, I believe, if you use the entire decimal of that. So 0.74. And specify what triangle we used. The blue one. So A, B, D. Okay, and once again store. Okay, so we're not done. Now I have AB, BD. The goal here is to get angle BAD. So now we can use sine law. Okay. So sine law, I am still using this. The goal is to get this angle. Okay. So sine BAD, angle BAD, over opposite side, which is BD, equals sine 3730 over opposite length, which is AB. Okay, so from this, please solve what's angle BAD. Correct, John, Kurt, KB. So it is Kurt, and then let's go boy. And Joshua. So the complete answer here is 27 degrees, 17 minutes, 15.3 seconds. Okay, so that's it for B. As you can see, it's a bit long. And then for C, find angle ABC. Okay, so let's isolate that. A, B, C, right? Angle ABC. ABB. ABB. Okay. So ABB means this one. That should be ABC. Okay. I was looking the wrong way. ABC. So now we have to get this angle. So there are a number of ways to solve for this. You can, for one, you can use sine law. So sine theta over AD, we already know what AD is, equals sine 37 over this. You'll get an angle, and that angle subtract by 75, you'll get that answer. Okay? Another way to solve for it is using what I have here. So let's write given from this. I'm using this one. This is 4930. Okay, I already know this side. Now, okay, in order to get this, the next goal now is to get this side. Okay, so let's try doing that now. Let's solve for angle AC. So to solve for AC, let's use one more sine law. So using this figure, so I'll write it here. AC over sine 34 degrees, 30 minutes equals, and we have a given side or assumed side 1 over sine 63. From this, what's AC? Correct. Kurt, Zaira, 2 points. Wells. Maro, correct. It's 0.64. Okay, and then as usual, store. Okay, now I have AC. I can use sine law here. So sine ABC over opposite side AC, we just solve for that, equals sine 4930 over opposite side AB. And you already know what AB is. Then please solve what is angle ABC. Okay, correct. Sorry, I was gone. Correct, Jasper. And Geraldine. Lazaro. Viernes. It was 40 degrees. 12 minutes and 44.7 seconds, or 40.21 degrees. Okay, so that's it for number 1. Any questions for number 1? Please answer in the chat. How about the others? Do you have any questions? Please answer as well. How many assumed length pwedeng gamitin? Only one. You can only assume one side. Because whatever you assume here will dictate also the lengths of the other sides. Okay? So this is one. There's gonna be an equivalent sides or an equivalent length to everything. So you can't assume them anymore. So just one side. Okay? Yes, for convenience, we assume side equals 1, because as you can see, and it's easier to compute it that way. You can assume 2 as well. So this will all just be 2. But as you can see, if you solve, you have to write 2 times sine 33 to solve for BD instead of just sine 33. For this, if you're only looking for angles, there's no wrong side. If there's no given side, only given are angles, and the only thing we need to look for are angles, there's no incorrect assumption of a side or incorrect length. So it's a different story if there's a given side. So you can't assume anymore. You have to use the given side. Okay? All right. No more questions. Let's move on to number 2. All right, number 2. Triangulation stations ABCD had the following angles. Find CBD, BDA, BDC. So again, we're just looking for angles. So let's try to draw this once more. So A, B, C, D, A, B, C, D. Okay, let's see if this matches up. ACB is 50. A, C, B, 50. BAB, 20. B, A, B, 20. BCD, 30. BCD, 30. ABC, 50. ABC, 50. CAD, 60. CAD, 60. And then let's close this. Okay? There seems to be no conflict, right? There's no overlapping angles given. These are all possible. So we can use this drawing. Now the question is, find CBD. Oh, let's start with that. CBD. So this one. Okay. So remember the way we solve for this is using triangles. One triangle we can use is this one, right? But the problem is there's very few given. There's only one angle, and that is this. Okay? So that means I have to get information from other triangles to solve for angle B. Now, if I manage to get uh, and side BD, right? If I get this, I can solve for this, okay? Because I'm gonna assume again side CD as equal to 1. Because again, there's no given side here. I'm not asked to solve for a side, so I can assume. And I'm gonna assume CD is 1, because that's the most convenient for me, because I can directly use it in this triangle. Okay, so you can put 1 on any side that you want. Okay, I'm gonna put it here, because again, it makes it easiest to solve for this angle. So once again, I have this side, this angle. I have this angle. If I can solve for angle BD, I can use sine law. So now we have to solve for BD. Now, unfortunately, it's not a straightforward process again. So BD shares this triangle as well. But again, there's no side there. So nothing to solve for that. So one thing we can do first is to solve for side, sorry, AC. Actually, I'll just put 1 here. Assume AC as 1. So my first computation is easier. And so I'll solve for side CD first. Once I get CD, I can use sine law to get AB. And once I get AB, I can get AD, which then allows me to use cosine law to finally get side BD. Okay, so that's my procedure. This is the final goal. I'll solve for these first. Upon solving for that, I'll get this side, and then now I have 2 sides and an included angle. I can solve for this. Alright, let's start solving. Alright, CD. So using this angle, ACD, this is 1, this is 80, this is 60. Okay, so side CD over sine 60 equals AC over, can anybody tell me what this angle is? Correct, Maria, Pagalanan, and Geyser. Pagalanan, Geyser, De La Cruz. It's 40. How do I know this is 40? Again, sum of interior is 180. So 180 minus 80 minus 60, that's 40. So this is sine 40. Please solve. What's CD? Correct. Denzel and Maro. Lahong Kasople. Okay, it's 1.35. So as usual, store. Okay, next goal to get AD. Okay. So AD, I'm gonna use this. ABD. This is 20. AB. Not that. So I can still use AC. Okay, A, C, D. This angle is just 60 plus 20, so that's 80. This is 50. This is 50. We have an isosceles triangle. If you remember, if we have an isosceles triangle, the two sides are equal. So just from that, just from observation, you can already say AB is 1. Okay? Now, in case you're doubting that, you can also use sine law. So AB over sine 50 equals, again, this is already 1. So 1 over sine, opposite angle is this, so 50. So AB is indeed 1. Okay? But it's easier if you can identify this as an isosceles triangle because two equal angles for your triangle. Okay, now I got AB. Next goal is to get AD, this one, so that I can finally solve for this. Okay, next I'm gonna use C. I need AB. Okay, so I'll use this triangle again because AC is also AD is also there. Okay, so AD over sine 80, right, equals 1 over sine 40. But yeah, that's what I'm doing. I'm solving AD from the first triangle using this one. Okay, please solve what's AB. Okay. Oh wait, I'll answer your question in a while. Correct, Kian and Jericho. Kiben Laguna. Kiben. Kiben. Laguna. Right. The question is, why did I go through this? This one. Because I also need AB. I need both AB and AD to get this. Okay, so that's why I went through that. You can solve for CD then AD first, and then solve for AB. And I just did it this way. So correct, it's 1.53. Okay. So now, using these two information, I can solve for BD using cosine law. So cosine law. Okay, I need BD. BD squared equals AB squared plus AD squared, right? Considering this one. So A, B, D. Okay, so this is 20. Right? So two sides included angle, I can get this. So BD squared equals AB minus 2, AB times AD cosine 20. Please solve what's BD. Correct. KB Gusto ba? A-B-E. Ako ka na. Geraldine? Buka na din. Joshelle? And Denzel. Okay, it's 0.68. Okay, so we're not done. After that is now I can get this using sine law. So now using this angle, this triangle, the red one, and this is our goal. So sine BCD, CBD, yep, CBD over opposite side, so side CD, and I already know CD equals, okay, we know this as 30, so sine 30 over opposite side BD. And again, I already know BD. So from this, please solve what's angle CBD. Anyone else want to solve? Use the stored values, because the answer here is actually a whole number. You'll only get back if you use the stored values. So correct, Denzel, so 2 points. Kurt, 2 points. Plus RDL, correct. Geraldine, correct. Zaira, correct. Giselle, correct. Okay, anyone else who want to answer? Okay, no more. So I'll just use the first two. So correct. Denzel, Kurt. Lahat, basta lang. Okay, so the answer, again, that's why I want you to use stored value, because you're going to get a whole number 80. Okay? So that's letter A. Next, let's answer letter B. BDA. There's a question, why all angles are congruent? That's just a coincidence. Okay? It just happened that way. It's not a rule that they should be congruent. But good observation. Okay. So now let's solve angle BDA. BDA is this one. So BDA over here. Okay, now it's easier to solve. What's angle BDA? Correct. Zaira, John. Okay, now if you're wondering why it's 30, because that's using this triangle. 180 minus 20 minus 50 minus, we just solved for that, 80. So that's 30. Okay, so 30 degrees. Next, letter C. Find angle BDC. BDC. Oh, this total thing. Okay. Let's solve. To solve for that, that's just angle BDC. Wait lang, wala pa. What's angle BDC? Correct, Gabriel and Jericho. Sampan, Dabu. Sampan. Dabu. Correct. 70. Oh, it's not 120. I got you there. It's 70. Why? 180. Oh, you can do it one of two ways. One is 180 minus 30 minus this, which is 80. So you'll get 70. So that's one way. Another way is, we already know this is 40, right? I just didn't write it. This is 40. We already know that. And we just figured out what this is. It's 30. So that's 40 plus 30. So 70 degrees. Okay? So that's it for number 2. Do you have any questions for number 2? Please answer in the chat. Okay, no questions. Let's have the last problem for today. Okay. Number 3. And then let's continue 4 and 5 on our lecture day. So number 3. A and B are 2 points located on each bank of a river and near the abutments of a proposed bridge. To determine its distance, a baseline CD 180 meters long was established on one bank of the river. And the transit was set up at station C and D, and the azimuths were taken as follows. Find distance. Okay, so now we're finding distances. There's no more assumptions here. We have a given distance 180. Okay, and then there's also no more assuming of placements. So this is on an actual location. So positioning is important now. Okay. And luckily for us, this is an azimuth. So it gives us the actual position of everything. So to illustrate, let's start with CD. So that means we're starting at C, because if you remember azimuth, the first letter is where, for azimuths and bearings, the first letter is where you took the measurements on. Okay. So remember, azimuth always taken for our case in the south line. So south line, 210, measure that out. So that's somewhere here. Somewhere like that. Yeah, this is 210. Okay. So meaning you have to draw a line like that, following that angle. So this is your A. Sorry, that's your C. Yeah, this is point C, and then this is point B. Okay. Next, CA 260. So let's draw that as well. Let's make it colorful. So 260 is like this. And not quite on the positive x-axis because that's 270, right? This is 90, 180, 270, 360. So 260 somewhere here. Okay? Yeah. So I'm gonna draw it that way. 260. Yeah, kind of like that. Okay. And I'm not gonna place CA yet. Okay, because I got another measurement or another angle, which is DA. So I'm gonna use DA first. I'm gonna skip CD. Okay, so DA is 301. So let's draw that. So starting from D, okay, so D over here, 301. Kind of like that. Yeah, over here. Okay. Greater than 270, less than 260, kind of like that. This is 310. Okay? 310, 301, 301. And then, that's the reason why I haven't written or placed the point A yet is because A is going to be the point of intersection of these two lines. So I'll just extend that. And that's A. Okay? Next, now let's try doing BC. CB is 290. Okay. 290. Let me write this first. This was 260. So this is even greater than that, 290. Yeah. And then that is where that line is. Again, that's 290. Again, I won't write out the point yet because I got another azimuth, DB 315. Let's do that. So B to B 315. So find like that. Yeah. And this is your D. B. Okay, and then let's close this up. Okay. So that's how you draw your figure using only traverse. So once again, the goal here is to get distances. Let me write the given distance. That was 180 CD. Okay, so CD 180. Okay. So before we try to solve for anything, these are all azimuths. What I need are the interior angles. So let's solve one by one. Okay, I'll start with this one. So to get this is just the difference between this angle and this angle, right? So that's 290 minus 180. So that angle is 290 minus 260. So that's 30. Okay? Wait lang. 260 minus 210. Yun, my bad. This one minus this one. Yeah, then this is what will remain. So 260 minus 210, that's just 50. Okay? So follow along. In the same manner, to get this, that's now just 290 minus 260. So 290 minus 260, that's 30 degrees, right? Next, let's get this. Okay. So this is just 315 minus 301, right? 315 minus this one. Yes, that's 14. And then finally, this one is not as obvious, okay? So that is, you might have a different way of figuring out what that angle is. Okay, so for my way, I'm gonna get this first. Because as you can see, this is 315. Whatever is left is this angle right here. So 360 minus 315, that's 45. So I'll write it here because it's not that obvious how to get that. Okay, I'll draw it here as well. This is point D, and this is the 45-degree angle. And then to get this, that's just 210 minus 180. Okay, so if I draw a straight line here, I can get this angle, which is also the same as this angle because of alternating interior angles. Okay, they're the same. To get this, that's just 210 minus this, which is 180. So this is 210. This is 180. Okay, and that is 30. Okay, so this is 30. So again, 210 minus 180, that's 30. So this is 30. Combining all of that, this total angle is 75. Okay, so that's how we figured out those azimuths. Oh, so very good. Right. Okay, so now what? Again, we're looking for sides. First is side AD. Okay, let's get that. First AD here. Okay, that's the goal. So to solve for that, like what we did earlier, let's isolate certain triangles. I'm gonna isolate this one. So this is A, B, C. This is 50. This is 75. This is given 180. Okay, can you give me what's this angle? Correct. Geyser, Jasper, De La Cruz, very nice. Two points ka na. Two ka na din. And 5. Okay, correct, it's 41. So this is 41. And then you might have guessed it, the way to solve for this is using sine law. So AD, that's what we're looking for, right? Yep. AD over opposite angle. So that's 50 equals 180 given over opposite angle sine 41. Please solve what's AB. Ah, yeah. Okay, so there was a question, bakit di nakasama yung 14? Okay, this is 14. This is what wait lang. Oh, that's 14. That's 18. Yes, kasali yung 14. 180 minus 50 minus 75 minus 14, you get 41. So yes, it's included. Sorry, this is 75 plus 14. Thanks for the correction. Okay, yeah, thank you. Great. So got it. Micah, correct. Who else? Okay, Jericho, correct. It's 210.18 meters. Next, letter B. Looking for BD. BD, that's this one. Okay. So I'm gonna isolate this. Okay, again, this is 180. C, D, B. Okay, so this one, this is the only 75. And then 50 plus 30, that's 80. What's this angle? Correct, John. And Giselle. Reyes for this side. It's 25. Again, how? That's just 180 minus 80 minus 75. That's 25. And then using sine law, again, the goal is getting BD. So BD over opposite angle is sine 80, or is 80, equals given over opposite sine 25. Please solve what is BD. Correct, KB and RDL. Escobar, Lavi. 419.45 meters. And then finally, letter C, we're looking for AB. AB. Okay. So AB, not sine law, because I don't have much angles. So instead, I know BD, I know AB, right? These two are solved for already. And it so happens I got an included angle as well. So we can use cosine law. So AB squared, I'll just write it here. Okay. AB squared equals the two sides. So AB squared plus BD squared minus 2 AD BD cosine, what's between them? 14. Please solve what's AB. Correct, Kian and Jericho. Daguno, hidden. Daguno, hidden. It's 221.43 meter. And that's it for number 3. So if you've noticed, this topic just involves a lot of geometry, your topics in your previous math subjects. So try to review on that so that this subject is easier. Okay, so this is the application of your math subjects. All right, so do you have any questions so far? Please answer in the chat. Okay, and with that, I'll end the recording there.